Okay, so we're looking at compound interest. So let's imagine that we had a bank account with £1,000 in it, and it gained 3% interest every year. After 1 year, 3% would be £30 interest, so the balance would be 1,030. You could actually take a shortcut there and just multiply 1,000 by 1.03. You'd get the same answer. You'd get it 1,030. Now, after the second year, well, at the beginning of the second year, we got our new balance of 1,030. And so we'd work out 3% of 1,030, which is just, or we could take the shortcut and just times it by 1.03. We'd get the balance at the end of the second year of £1,060.90. After 3 years, repeat the process, we get that value, and after 4 years, we get that value. Now, notice that each time, all we're doing is we're timesing it by 1.03. After each year, we're timesing it by 1.03. In other words, if we imagined an original balance of x, I've written x, but I'm going to change it to b, because that's how my notes say. Original balance b, 3% interest each year. After 1 year, it's going to be 1.03b. After 2 years, after 2 years, we're going to start off with a 1.03b, and we're going to multiply it by 1.03. That's the same as saying 1.03 squared times b. Remember, b is the initial balance at the very beginning. After 3 years, we're going to take the balance after 2 years and multiply it by 1.03. And we end up with 1.03 cubed times b. And after 4 years, we would have that. So you can see the pattern here. The amount of years would give you that power. After 1 year, the power is 1, 2 years is 2, 3 is 3, 4 is 4. So after 100 years, it would be 1.03 to the power of 100 multiplied by whatever the balance is. This is what compound interest does. And if you were to put that onto a graph, you would notice an exponential trend. A lot of people think that a couple of percent here and every year isn't going to make a difference, but as the years go on, the next year will make more of a difference than the year before, and so on and so forth, until eventually after 100 years, you're going to find that the difference between the 99th year and the 100th year is going to be, you're going to earn a lot more money than between the first and the second year. So that's what compound interest is all about. Now, because of this, we can see the difference here. So how to put together the formula. So 1.03, which is what I was multiplying by every time, well, that was equal to 100% plus whatever the interest was. In this case, 3%. So I've put 100 plus, but that's 1.03. 1.03 is the same as 103%. 100% is 1, and 3% would be 0.03. So the new balance is going to be equal to, this is now the general formula, 100% plus I, meaning the interest, to the power of how many years there are, multiplied by whatever the initial balance was. That is how you would actually calculate the interest of a bank account or anything like this, given if this kind of thing, if the interest was increasing or decreasing by a particular percentage every year. If it was decreasing, you'd do minus there. If it's increasing, you do plus there. Okay.